Uh, Hello, everyone. Sorry for being a couple minutes late. Just give me a moment to set up here. So I get started over here. Okay. Hello, everyone. Today we are going to be beginning a brand new chapter. It's one of my favorite chapters, actually. In the course is actually a very light chapter. It should be completed within one lecture. So let me just do the screen share here. So this chapter is about I'm getting a message. We hear you. Okay, yes, thank you. Thank you, Sadu. Okay, so this chapter is about refactoring. Um, okay. Oh, yeah. Sorry. Gotta unplug this to work correctly. Okay, so what is this whole thing about refactoring? So basically, a lot of times what happens is that we are either in a rush to produce software, like the people who do extreme programming or any agile sorts of development. They create software first, and then they think about the software that they created a little later on. So in the sense of they think about it in the sense of how can I improve it? Okay, I'm getting another text message. Well, not exactly, but it does involve some modularization of the code, Ya Abdurrahman. Yeah, it's not all about modularization per se. It's a byproduct. Modularization is actually a byproduct. But the general concept here is that my main goal in the agile community is to create software, create a product, create something that works, and then start to think about what can I do to make it better. Now you can ask, like, what do you mean make it better? We're talking about fixing the bugs. No, we're not talking about fixing bugs. Are you talking about, sir? Are you talking about adding features to the software? No, I'm not talking about adding features to the software. I'm only talking about improving the internal structure, the internal quality of my code, which will help me then with my 7 principles of design. I'm not sure if you've covered those with Dr. Anan, but things like flexibility, things like reusability, things like understandability. These are also very important things. Understandability is a big deal towards solving any other problems that we have, including debugging at some point, in case you do find a bug, right? So again, refactoring is all about improving the internal structure of the software that I have without actually changing the external behavior, right? And if this course is called software testing and quality assurance, it's actually this is the part of the course that deals mostly with the quality assurance part. All right, pretty much the only chapter that focuses on uh, um, quality assurance more than it does the software testing. All right. Um, Now, oops. Okay, so we're going to introduce refactoring, its importance, and give some refactoring examples. Okay. Uh, Now, this refactoring process is all about cleaning up the code. Okay. And matter of fact, what we tend to do with refactoring is that we get to target what we call bad smells in the code. Okay. Now, what are those bad smells? What do they constitute? These are certain ways that code is written that although it's functionally working properly, it's actually a symptom of a bigger problem later on. Okay, we know that this is a recipe for disaster. Okay, this is what we call a bad smell. Okay, this concept also exists in modeling, not just in software. It also exists in requirements, not just in source code. But nonetheless, it's most commonly applied to source code. The person who created this concept is called Kent Beck, if I remember correctly, Kent Beck. And then there's a big list of different bad smells that you can come across. And the whole point of the refactoring exercise is to identify an area in your code where there's a bad smell, and then you apply refactoring. And what does that application of refactoring entails? It entails obviously identifying the bad smell, then applying the refactoring, meaning you change the solution, the current solution, to a better solution, all right, that would improve the internal structure of the code. Okay. And I keep saying internal structure of the code because we're not changing the behavior, we're not adding features, and we are not fixing bugs. That's extremely important for us to understand. Okay, we're just improving the internal quality of our code. It does integrate very well with the agile development community. However, we can argue, like the research community would actually argue, that refactoring could just as be helpful for waterfall development or traditional development, not just agile development. Okay, we're going to come to this in a moment. Um, but again, why is it that we do refactoring? It makes our software more modular, more easy to understand. Okay, if you have software that is easier to understand, that understandability quality aspect is the key to everything else. It's what makes our software more reusable, makes our software more maintainable, makes our software more flexible to future changes. Okay, and when it comes to debugging, it makes our software easier to debug. Okay, I can tell you for a fact that when we are doing maintenance on software, 90% of the effort that is spent in doing maintenance is actually understanding what is it that we actually have right now. So you'll get a maintenance team that's looking at the code, trying to make sense of it, all right, trying to understand how exactly it's working, so that the change that they make doesn't actually end up messing things up and injecting new bugs in there. Um, so understandability is very, very important. And then once you actually understand the code, the actual change of the code, the changing of the code takes like 10% of the time. It's very, very easy at this point. All right. Another thing too is, remember, this is all about software engineering. Okay. The big part here is the word engineering. And what is special about engineering? Engineering is scale. And we're not just talking about the scale of the problem, as in the scale of the source code, but also the scale of the teams that we're working in. Okay, so chances are you are going to be writing code not just to be compiled by some compiler sitting somewhere, but it's going to be read by other people in your team, maybe read by other people from different teams. All right, and they need to be able to understand your code correctly. All right, now obviously there is a particular science of deliberately writing code not to be understood just in case it falls into the wrong hand, but that's obviously a completely different science there. In normal circumstances, you'd be actually wanting to write code that you would want others to understand. I'm going to take it one step further, and stop me when I told you the story before, but I was working in the United States. I was working at this stock exchange company, and my boss asked me to do something, a little project that I was working on, and I worked on it for about 2 weeks, and I submitted it. Everything was fine, everything was great. And so I moved on to the next project. Maybe a couple of months later, something happened, some rule change with the law, and my boss comes and says, that project that we worked on, we need to change it so it adheres to the new law that we just produced by the US government. And so I said, okay, I check out that code, which I have written, and I've been looking at the same code that I have written, and I have no idea what is it that I was thinking, literally, not just figuratively. Literally, I have no idea what is it that I'm thinking. Like, I'm looking at my own code, I was like, how is this software actually working? I was hoping to find a single line of documentation somewhere of code that I have written myself. Okay, so if this is happening to code that you've written to yourself, let alone imagine how it's going to be like when somebody else is reading your code. Okay, and like I said, refactoring helps us find bugs as a byproduct, because in order to understand why your software is not running properly, you need to be able to understand your software as it is. So if you can't read it, you won't be able to find the bug. But if you can't read it and it's clear, then you will be able to find the bug in there. All right, so a moment ago I said that refactoring tends to be a big deal in the agile community. We also at the waterfall or traditional development community also argue that refactoring could be helpful for even regular development, not just agile development. And the reason why it's good is because A, it's usually difficult to get the design right the first time. Okay. And so we're going to end up changing the design. And if I change the design, I should be changing the code as well. Okay. You cannot fully understand the problem domain. Okay. That also causes changes. You cannot understand the user requirements regardless of whether or not the user does. Okay. So this misunderstanding part is also a big deal. But again, all of these would cause us to make changes. You cannot really plan how the system will evolve in 5 years. And the original design sometimes is often inadequate. If you look at all these 5 points, all of these are saying is that chances are you're going to be making changes to the design that you have, the code that you have. Now, here's the thing about changes. The more you change, uh, the internal structure, the internal quality of your code degrades. All right, unless of course you're doing refactoring, which is specifically, it has a specific purpose of improving the quality of the code. So all of these activities, these 5 bullet points, is all about change, and changing causes a degradation in the internal quality of my code. I mean, think of my code as like a deck of cards that you set up into a pyramid structure. Okay, I'm pretty sure all of you must have played this game when you were young. You're trying to set up the cards that you have into a pyramid, and after you created the pyramid the first time around, it's at its best structure, right? You start to change around in the pyramid, then the structure starts to weaken almost to the point that it may collapse. Almost the same idea I can say about uh, uh, um, bridges or even buildings, regular building. The more you change in that building, okay, the structure becomes weaker, become more cautious every time you want to make another change because it becomes closer to falling down. All right. Is this clear for everyone before I move on to the actual refactoring examples? Everybody okay with this? So far, this is just regular talk. And I'm pretty sure you should be at this point. The only question that you have is, okay, what is examples of these refactoring the doctor that you keep talking to us about? Okay, let's go for it. All right. We're gonna go through a number of them. Okay, one of them is gonna take maybe like half a second or so. Okay. The list that we're gonna go through is not a complete list, of course. I'm not sure if we covered design patterns and SE 410, but it's a big list. And yeah, so we're just gonna go through a number of them, at least the most popular of them. Okay, so this is the first refactor. It's called the extract method. Okay. And let me just pull out the, let me just pull the laser pointer. All right, so if I have a fragment of the code, like this one over here, all right, and they tend to belong together into some sort of an autonomous logic, right? Like I'm printing the details of somebody, okay, the name, an amount, ID, whatever it is, okay, then I should take those out and put them in a method on its own, okay? Vis-a-vis like what Abdurrahman was saying, making the code more modular. Yes, in this case it would be, right? And then I would replace it over here with a line called print details, which is the name of the function, and that's it. All right. Now, there's two things. right? Obviously, this part of the code over here, if it is being required by some other part of the code, all I have to do is call on that function. That's one thing. Another thing too, when I'm reading the original function, it becomes easier to understand. So it says print banner, print details. Okay. Whereas over here, I have to read system.out.println name colon plus underscore name system.out.println and so on. Now again, because there's only limited space on a slide, you have to think a bit extreme when you're looking at these examples that we're going to go through, one refactoring after the next, after the next, after the next. This over here could have been 15 lines, could have been 20 lines, okay? And those are 20 lines that I would have had to repeat over and over again had other functions needed them. Those would have been 20 lines that I would have to read through when I'm reading the function print owing, and I would read the 20 lines just to figure out, oh, I'm trying to print out the details, okay? But when I look at this over here, the bottom one, I understand right away that this part of the logic is about printing details, all right? So the first refactoring is called extract method, all right? Next one is called replace a temporary variable with a query. Now, a lot of times we tend to have if and else statements, and this variable that we are using in the comparison, in order to come up with it, we use some sort of a function or some sort of a mathematical function. This is what I mean. In order to compute, for example, base price, which I'm using in my if else statement. Okay. Again, this would have been a temporary variable that would have been used maybe one time over here. Why not make the calculation of a base price again become a function? All right, become a function as you see over here at the bottom. It's called base price. And then in the query, in other words, in the branch, the if else branch, instead of just using a variable called base price, I would actually use the return value from that function, and I put it inside the if statement, and it says, okay, well, it's gonna compute the base price, come back over here. The good thing about it is that obviously in a case I need to use base price somewhere else, all right, I don't have to copy paste that mathematical formulation again and again. I just, all I have to do is call upon that function. All right. Next refactoring, it's called introduce an explaining variable. All right. You know, so much goes into a name. You'd be absolutely surprised. Okay. Now, you know, if you read this if statement over here, okay, platform dot to uppercase index of Mac, browser dot to uppercase index of IE was initialized and resized. Really, what this is actually saying, okay, it's asking is if this operating system is a Mac, and if the browser was an IE browser, and if it was initialized and resized. Okay, now try to read this upper if statement and compare it with the lower if statement. Okay, I can read the lower if statement like I'm reading English. Okay, is it a Mac OS? Is it an IE browser? Was it initialized and was it resized? Then do something. All right. Now the point here is all of this sophisticated code over here, I can just create an explaining variable to represent it. Okay. Now this is not about the variable itself having a good name. Okay, but nonetheless, it's all about this formulation. Although it's not a mathematical formulation per se, or a very complicated math, but it's about, you know, you're getting something dot something dot something dot, and what is it that you're trying to do? What is it? Does it mean to say bigger than -1? Okay, we're just trying to say, is it a Mac operating system or is it not a Mac operating system? Okay, so what if I read a variable, a Boolean variable called is Mac OS? Okay. by default, if it's true, that means yes, it is a Mac OS, and it's false, that means it's not a Mac OS. Okay, and as such, I can read an if statement at the bottom here. That would make perfect sense to me. Like I'm gonna do something only if it was the Mac operating system and IE browser, and if it was initialized and resized. All right, next, um, next refactoring. Decompose a conditional. Okay, so I'm reading this conditional via this if and else statement, and in order to construct, to create and build the conditional, it becomes bigger and bigger. It just starts to get really, really big. Okay, it's not usually as easy as if x is bigger than 5. Okay, and I can tell you this from my professional experience. A lot of times, in order to come up with an argument, a parameter of an if else statement, you need to grab an object, then grab another object it refers to, okay, like x dot y dot z dot a dot b dot c, then dot a function call, right, and then dot something, okay, and that's just one argument of the entire if statement, okay. So date dot before summer start and date, or date dot after summer end. Okay. What I'm actually trying to say here, if it's before summer or if it's after summer, all I'm really caring about that it is not actually summer. Now I can tell you from professional experience again, sometimes I ended up writing if statements. The if condition itself is 5 lines long. Can you imagine? Can you imagine 5 lines long creating an if condition? All right. Again, if it's gonna take me 5 lines to write the condition, it gets very, very difficult to understand and read that condition at any later point. Okay. So what I want to do is I want to take this complicated condition, okay, throw it somewhere into some sort of a function that produces to me just a Boolean. Okay, the Boolean result of evaluating this condition, whether it's going to be true or whether it's going to be false. All right, so I'm going to call a function. It's going to be called not summer. I'm going to just give it that date, which I'm used over here and used over there. Throw it that date object, and it gives me back a Boolean return true or false, whether it is summer or not summer. All right. And again, when it comes to the readability of this, look at this and just read if not summer, then do something else, unless otherwise, if it is summer, then charge the summer charge. Okay, just becomes a lot easier at this point. All right, so we've covered about 5 refactorings so far. I just want to check with you guys if everybody following me on each one of these refactorings. Yeah, let me see what you've written. Okay, good. I mean, all of them are pretty straightforward, maybe except for 1 or 2 that we're going to get to towards the end. But more, and honestly, most of them are pretty straightforward. All right. All right, so here's one of the, I guess the slightly more complex. It's still pretty easy. Now, anyway, what this refactoring is called replace data value with object. Okay, so I have an object called order, and one of the attributes is a customer. And so far, I just put the customer as a variable of order, and as a primitive variable, and I just call it string. But customer, the concept of a customer is a lot more than just a name, right? And if I should foresee in the future that a customer is going to have a name, it's going to have an address, it's going to have maybe a credit card information, billing information, a phone number, then the actual customer shouldn't just be a variable, should be a full object in its own right. I'm going to call that object customer with the original string representing its actual name. Okay, and then later on, there's going to be a whole bunch of other variables of the object customer, which customer itself as an object is a variable of the object order. Okay, so I haven't lost anything. All I've done here, okay, instead of having a whole bunch of variables called customer name, customer ID, customer this, customer that, all I can do now then is take all these things that relate to the concept of a customer, make it as a class of its own, and then put the information about the customer in it. And it's a concept of information hiding. Okay, you know, basically just ask the customer for whatever it is that you need from that customer. So I just end up going customer dot name, customer c dot address dot phone number. All right. All right, next up, we have an array, replace an array with an object, okay? Now, assuming, for example, you have a football team, okay? There's a whole bunch of information about the football team. It's got its name, wins, losses, draws, goals scored, goals conceded, and you end up creating a variable of so an array of strings, and then each one of those elements of the team, its name, its wins, its losses, its draws, you're putting it in a different cell of the array. That's obviously not the proper way to do it. Again, what you should be doing is you create an object called team, all right, and then in that you have the different variables representing the attributes of the team, okay, be it its name, its wins, and so on. The good thing about this is of using an object instead of an array is you don't need to remember the order of the elements that exist in that array, okay? For example, 15 here represents the number of wins, okay? I need to remember that it's cell number 1. If I pull up what's in cell number 2, then I pulled out the wrong variable, okay, the wrong piece of information, okay? Whereas with the use of an object, I don't have to guess where the win information is located. All I have to do is I just go team dot get wins, all right, and I will be able to pull out the wins. Right, it's not really my object. How is it that the Java virtual machine decided to sort the order of the information of the team? Okay. Next up, oops, pressed up. Replace magic number with a symbol. Okay. 9.81. Those of us who have done any physics in our lives, it's a very special number. It's the gravitational constant, okay? We tend to round that up sometimes to 10 just to make the calculations easier, but nonetheless, the proper number is 9.81, and it's a constant, it never changes, all right? But the issue is that if I see a magic number as such, maybe I'll understand it, maybe others won't understand it. Maybe it gets lost between a number of other magic numbers. So bottom line is we're writing code so that it could be read better, okay? Instead of reading return mass multiplied by height multiplied by 9.81, and God knows what 9.81 means, I should actually be reading it as return mass multiplied by gravitational constant multiplied by the height. So I figured out the formula right there, okay? Okay, and again, I said this before about a previous refactoring, I'm gonna say it again. A lot goes into reading, a lot goes into a name, all right? You would be surprised. You'd be surprised how many people call things X and XX and XYZ, okay? Just as a shorthand. All right, this one is a pretty little refactoring. It says replace a subclass with fields, okay? Now, we're all for object orientation and we're all for modularization, Abdurrahman, but sometimes we take it a little bit over, a bit of an overkill. Okay. And I create a new level of inheritance, like say from the class person. I have two different subclasses. One is called male and another one is called female, right? But really, the only difference between those two entirely new classes that I've actually produced is that one, when I call the get code for it, it returns the character M, and the other one, when I call the get code function for it, it returns the character F. Okay, so obviously, that's a bit of an overkill to create two different objects and a new level of inheritance, just so that when I execute this, it returns one variable, one character, and when I execute the other function, it returns a different one. Okay, what I really should really have is just have the codes in that class person. Okay, M and F, explain what the M and the F means, although it's supposed to be self-explanatory at this point. And then basically the code that I'm going to get should just represent if it's a male or a female. So I would produce an object of type person, and I'm going to put in the constructor, going to pass the variable M, so that this person object that I've just created is a male object. If I passed F, then this person object that I just created is of type female. Okay. There is something about levels of inheritance, although we like it, and we've been teaching you that since SE 120, its overuse could be problematic. Its overuse could be problematic, and it makes our code harder to read. Now, imagine you have, let's go a little bit extreme. You have an inheritance tree of 20 different levels. Okay. Look at the very bottom class that you have. You have a variable called X at that very bottom class. You have no idea where you got it from. Okay. The other thing is, if it did exist, say, in the class and the inheritance tree in level 3, and it says X equals 5, you think you got it from there. But if there is a different class in the inheritance tree level 13, and it has the same variable called X, and that one has X equals 10, it was actually overridden. We didn't actually see it. Okay, so the point that I'm trying to make here is the deeper we go, inheritance is good, but the deeper we go, the harder it is to understand what are the inheritances that we're actually having. Okay, and what is it that we're actually inheriting and from where. Okay, in other words, it does hamper our understanding of what we're actually seeing at those bottom concrete classes specifically. Okay, so if I created an extra additional inheritance level that could be considered a bit of an overkill, that is not really serving a big purpose, then doing without would actually be better in that case. All right. Consolidate duplicate conditional fragments. Sometimes I get an if-else statement as such. I say if something something, right? Do these things and then send. Else if, do these other things and then send. All right. Else if, do these other things and then send. All right. Else do such and such and then send. Well, something I just realized, I have that send at the end of every single branch of my if-else statement. So it's going to happen anyways. It's not really a dependent of the evaluation of a particular condition. So I should take the send from here and there, take them out of my if-else statement and just put it at the very end of my if-else statements at the very bottom. Okay, so if-else and an if-else over there, and I just gotta put it at the end, right? Because it doesn't matter what happens in my evaluations of the conditions, I'm gonna execute that send, and I'm gonna execute it one time only. Okay. Now I gotta be careful about this. Okay, assuming I have an if-else condition that's consistent of 3 branches, 2 of them would entail a send at the end, but the third one doesn't entail, then I cannot do this refactoring, okay? So this refactoring is only possible to take that line of code or that fragment of code outside the if statement completely and put it at the very end, if and only if it is applicable in all of the if else branches. All right. The other thing too, it has got to be also at the end or at the beginning. All right, because if that send statement is happening in the middle of a number of statements within an if condition, it could mean, okay, and I'm saying maybe, that its particular presence in the middle, is important. Okay, its order is important. So I can't just wait till the end and execute the send. Okay, so again, what we want to do is we want to take that fragment out. Okay, but we got to be careful when we're doing it so it doesn't actually change the behavior of the code that we have, whether it's at the very, very beginning, what's happening at the very end. You got to be very, very careful about this. In case all the rules apply, then taking that fragment out is obviously very, very helpful. Okay, it makes my if else conditions smaller. Okay, and just in general, my size of the code becomes smaller. Okay, all right, and again, here's another refactoring that falls under the criteria of renaming or the category of renaming. Okay, again, a lot goes into a name. Okay, if I read something like get INVCDTLNT, I'm not really sure what that means. But if I read it as such over here, it says get invoiceable credit limit. I know what this means. Okay, and the real reason why we end up with functions as such, okay, is because a lot of times programmers, and you might have experienced that yourself when you were doing your assignments. In other words, you're looking at a piece of code that you feel you're never going to visit again and nobody else is going to visit again, and this is just going to be buried for the rest of their lives. Is that, if this is the case, why bother coming up with something inventive, okay, and something explanatory, something that has more letters in it, okay? And this is why a lot of people then starts to resort to things like a function called x and a variable called y and something else called xyz. Okay, so again, just make sure that the name of the function explains what the function does. Okay, what you really don't want to do is somebody having to dive into that function over here just to understand by reading the code in it to understand what is it that this function is actually doing. Okay, so I should be able to understand it, or somebody else, not just me, should be able to understand what its purpose by just reading the name of the function. Okay, and like I said, if you had to dive down, you've already lost. Okay, sometimes we end up actually, if you have a properly written piece of code, you get to read the main function, and the main function is a whole just a bunch of different functions being listed, and all you have to do is just read those very explanatory function names, and you understand what this code is doing and how its logic is set up by just reading the function names. All right. In object orientation, it's very common that when we have a variable called x, you've probably seen this with the different IDs that you've used. We have something called setters and getters. Okay, we don't like to touch the variable immediately. If you want to read its value, we use the get. If we want to set a value for the variable, we use the set. Okay. What I should do is I have my setters and getters separately. Okay, I have my get function and my set function separately. What I shouldn't do is have my get and my set being stuffed together into one function. All right, so I'm gonna set something and then I'm gonna go return its value right away. That doesn't make sense, and that's not good. Okay, you want to have your setters and your getters be separate. All right, this next refactoring is called parameterized method. Okay, so sometimes we over modularize, and okay, we have, say, a mathematical function, and all that is actually changing is a parameter. Okay, but I end up creating a different function for every possible value of that parameter. Okay, so let's just say I'm raising taxes. You know, like right now we had 5% VAT tax. Now we have 15. Okay, all right. I shouldn't have had a function called 5% raise. I should have had a function called just raise and then give me the percentage, so that if the percentage does change, okay, then I don't have to create a different function called 15% raise. Okay, all I have to do is just change the number of the percentage. Okay, because now going to be both at the same time. And even if both were applicable, okay, still I shouldn't have 5, 10, 15, 20, 30, 40, 50. Okay, just have the one function and make that thing that is changing become its parameter. All right, become its own parameter. And up to the next refactoring. This next one is called preserve the whole document. Okay, now let's just say I have a very I have an object. So preserve the whole object. Did I say document? I think I said document. Okay, preserve the whole object. Okay, so sometimes I have an object. Okay, let's just say a student object. It has a whole bunch of attributes. Okay, student has a name, ID, GPA, courses that they've taken, so on and so forth. All right. The improper way, if I need to deal with the object or deal with information that exists in the object, is to extract each one of those attributes, store them in a temporary variable, and then call a function. All right, let's just say those variables are A, B, C, D. Call a function and then pass in its signature, in its interface, the 4 variables A, B, C, D. All right, that's not good. What I should be doing is sending the entire object. So that function should have just one parameter, and that one parameter is the object. And then inside the function, I can then break it down and retrieve student s dot get name, student s dot get GPA, s dot get ID. Okay, so preserve the whole object and then send it there in one shot. All right, when I'm reading the function name and I'm reading there's 15 parameters, I have no idea what I'm receiving. But if I read a function name and there's one parameter and the parameter is called student, I understand right away that this function is working on a parameter on a student object. Okay, here's another reason why this is good. In case before the function call, I pull out the different variables from the student object, store them in a local variable, and then send those local variables as parameters to that function call. Okay, then whatever changes that I'm making to those variables, they're not really affecting the original student object. Okay, but if I do send the object itself, okay, I send the student object to that function, and then I decided to change the GPA, then I've changed that object. Okay, at a later point in the code, if I wanted to print the GPA of that student, it's going to reflect the newly changed GPA of that student. All right, and again, we've covered about 5 or 6 refactorings. I'm not really sure. It's gonna pause here for a second again. I'm gonna ask you guys, is what I'm saying here, is it clear? Is it, you know, am I, everybody following me so far, these different refactorings? Hello? I can't hear you. Somebody thought, okay. Yes, what if we don't require the entire object? So yeah, here's the thing, yeah, Abdurrahman, right? Now, if that object, you only needed one thing, like you know for a fact you just wanted the GPA, and not to change the GPA, but just to read something about it. Okay, for example, you're calculating the average of the student GPAs. All right, then it's fine. You can then just grab that particular variable and send it to that function. Okay, but a lot of times you see that, for example, I'm actually dealing with different aspects of the student object. So instead of breaking it down and then sending the broken pieces of information to a function, just send the whole object. Just send the actual whole object. All right. Okay, next. Okay, introduced parameter object. So sometimes you'll see some parameters like a start date and an end date. They tend to naturally go together and they tend to be called together each time. So I have, like, say, three functions over here, and every time I'm sending the start date and the end date, start date, the end date, maybe I want to combine them together into just one object that makes sense. Okay. And again, you'll say maybe it's a bit of extreme. All I've done is I've combined two objects into one. I mean, assuming this could have been 5 or 6 or 7 different parameters. And if those 5 or 6 or 7 parameters make sense in being an object in themselves, then I should have actually created that class and have that object being sent and used as a parameter instead of the different attributes of that object. Okay. So I want to introduce a parameter object instead of just the multiplicity of parameters that I'm actually sending. Right, next up. So this is one of the more interesting one. Okay, so this refactoring is called replace inheritance with delegation. Okay, now the word delegation just means basically association. Okay, having one class just have a variable of a different object. Okay. So sometimes what happens is that you'll get a class that is being inherited by a different class, but really it was just using one thing and one thing only. And if this is the case, perhaps I shouldn't have had that inheritance in place. Okay, maybe that inheritance would have been a bit of an overkill. What I should have done is, if the stack required that is empty function, I shouldn't inherit it, should make the vector be a variable of stack. And in case we want to use the is empty function of vector, I will then, in my code of stack, I just use vector dot is empty. Okay. The whole point behind this is, sometimes we end up forcing inheritance structures that don't exist. Okay. For example, imagine this upper class is called laptop. Okay, just humor me on this one. And the bottom class is called a dog or a cat. Okay. How much stuff can you imagine the cat is inheriting from the class called object? Sorry, a class called laptop. Okay, not much, correct? Not much. And the reason is because a cat, logically, is not a type of a laptop. The only maybe common thing between a laptop and a cat is that a laptop has a weight and a cat has a weight. Okay, so this is an inheritance that doesn't make sense. This is an inheritance that doesn't make sense, right? And so a lot of the times, again, moving away from the laptop and cat example, when we have an inheritance between two different objects that aren't really a type of each other, like X is not a specific type of Y, we end up with this situation. We end up inheriting a lot of information from the parent class that we don't really need. And all we wanted is to use a function from the parent class, use an attribute from the parent class. In case this is the case, I should have an association between those two different classes, not inheritance. And what does association mean? Meaning one of those variables, one of those objects, I mean, will have as a variable an association of a different object. Okay. And again, this is one of maybe the more complicated refactoring. So again, I want to ask if it's everybody's okay in understanding this one particular refactoring. This is a bit of a clever one. All right. Anybody else other than Abdurrahman understands this? Okay. Now, as we're saying, replace inheritance with delegation, the next refactoring is called replace delegation with inheritance. This is when we have had the opposite situation, okay? This is when we have an association between two different classes when the real relationship between those two different classes is that one is an actually subtype of another one, okay? So employee, for example, and a person, an employee is a person, okay? Everything about a person is true about the employee. Everything about class human is true in the class man, and everything, or male, and everything about the class male is true in the class man and boy, okay? So human, class human, the top class has, it has eyes, nose, ears, mouth, head, legs, arms, all right? Each one of these things will be inherited by the subclass, okay? So to have an association doesn't make sense, all right? And the problem with having the association is that I have to go and keep grabbing each one of those variables from the parent class, okay? So I'm gonna go parent class, for example, it's called P dot, get eyes, get nose, get mouth, get ears, get teeth, get tongue, okay? That shouldn't be the case. I should have inherited all of those attributes, all of those functions right off the bat. Even the functions like run, sit, sleep, eat, okay? These are functions of human beings, not just male. Okay, so I should be replacing this delegation, i.e. this association, with an inheritance, okay? And I would say that an employee is a person, a male is a human, and a man is a male, all right? And everything that I'm gonna be inheriting is going to be useful for me in the subclass. So this particular refactoring is the exact opposite of what we just covered in this last refactoring. And it's a judgment call, okay? It's a judgment call. So if I'm seeing that I really do need to inherit almost all, if not all, of the information that exists in a parent class, then inheritance would be the way to go. If I'm realizing that I only need one thing and that the majority of what I need, and the majority of the things that exist in the parent class are things I don't need, then I should go with this refactor. It's called replace inheritance with delegation. Chances are you're gonna come up with this situation if the two objects are really of type of each other, okay? Like human and male, human and female. A female is a human, a male is a human, okay? You're gonna end up with a situation like this if you have two objects that are not of type of each other, okay? Like laptop and a cat. A cat is not a type of a laptop, and a laptop is definitely not a type of a cat. All right. Okay, so moving on. When we are applying refactoring, we can face some obstacles. First of all, you don't get the code nice and easy looking as such, and as we've done in the different refactorings that we've seen before. Changing code is hard because I have to understand where it is that there is bad smells. So I gotta understand it. Gotta realize that these some lines of code could be a candidate for refactoring. Okay. One thing that we've noticed is when I'm looking at things like this, right? The code is nice and stacked up together, and I see, aha, this over here, this is where that refactoring is. This is the bad smell, and so I'm going to apply this. But in reality, this line could have been at the very top of the code. This line could have been in the middle, and this line could have been at the very bottom of the code. Okay, this could have been in object A. This could have been in object B. This could have happened in object C. Okay, so it's not easy to spot the actual refactoring. So understanding it is a complexity, is a challenge. Understanding and then spotting the refactoring is a different challenge. And then finally you get to change it. Okay. Now, when you do a change, anytime you make a change, you run the possibility of introducing errors. Okay. So I make the changes, but I can't just leave. I gotta run the test again to make sure that it's running correctly. I have to maybe rewrite the test again. Okay. New objects have been created. Different variable names have been changed. Inheritance have been changed with associations, and associations have been replaced with inheritance. Okay. That means that the old tests that I had may be no longer useful. So I got to recreate those tests again, rewrite them, and then rerun them. And then all of this is an added effort. Okay. We have a culture issue. It says, your boss comes to you and says, I pay you money to create new features. Customers pay for the new features. You don't pay for an improved quality of the code. Okay. A lot of the refactorings that we've been doing ends up requiring modularization, requiring functions to be created, objects to be created. Okay. For us, it seems the performance is the same, but in reality, what actually happens is that there's something called a stack in my CPU, and things get thrown on the stack and then removed again. Okay. If I'm writing code that is just line by line, easy, no function calls, no object, not much goes onto the stack, and so the performance is fast. When I create an object, when I make a function call, a lot of things goes onto this stack. Okay, and that considerably reduces the performance and slows down the execution. Development is always under time pressure. Okay, you'll see that next year, or actually, sorry, this year, when you're doing your capstone, all right, is that you're using all the time to actually implement the features that you set out at the beginning to say that you're going to be implementing. All right, you'll probably be unlikely to face a situation where you say, all right, let me stop here and then refactor my code. Okay, I got to deliver next week and I still have so many features that I haven't implemented. Okay, so how about I do the refactoring after the delivery? All right, but then another problem rises up. Okay, if I'm going to be doing this after delivery, then why should I even bother? Let it be somebody else's problem. Okay, from a programmer's perspective, all right, there is maybe some reluctance to do refactoring, and a lot of these reasons are common with the general obstacles of refactoring, is maybe some programmers don't understand how to refactor. Okay, and like I said, if the benefits are long-term, why put the effort now? Okay, why should I be putting the effort for somebody else a little later on to reap the benefits? Okay, even if it's going to be me, it's going to be looking at the code later on and reaping the benefit of the refactoring. Still, we're dealing with priorities here. I got a deadline. I got features to complete. So let that refactoring be on the side for now. Okay. Refactoring is an overhead activity. We're programmers. We're excited about programming because we want to create new features. Even us as programmers, we're in it to create new features. Okay, it's exciting for us when we write a new feature and we see it work. Okay, when you are doing SE 100 and your professors kept bugging you and preaching that we want you to document your code, document, and there's always a big reluctance, big level of laziness towards documenting your code, it's because you're not really creating anything new. Okay, you're probably thinking in your mind when you signed up to a software engineering degree or computer science degree, I'm going to be writing code to do things, not documenting the code, not refactoring the code to make its quality better. Okay, you are also afraid of being the reason of breaking the code by refactoring. Okay, so it was working and everything was working fine. You decided to make it a little bit better, but in trying to make it a little bit better, you end up making it worse, and you've introduced a bug, and now the code doesn't work. So you're afraid. So you become reluctant to refactor your program. You say, all right, look, it's working. I know it's working. So why rock the boat? All right. And I believe this is it. No, this is just a summary. Um, it's like I said, it's one of my favorite chapters. Very self-explanatory, very useful. One of these chapters that you can apply right away. Any questions about what we've covered in today's lectures, guys? Let me see. Okay. All right. So that's it for today. I'll see you inshallah on Wednesday. Have a good day.